and I just turned it off. Well, I
Just,
guess
just,
we'll.
just, just as a firm reminder, everybody. Charles told me just before this meeting. Oh, I spent hours testing this. Everything's perfect before we start. So,
I tested out. I did recordings. I have recordings saved to prove it. I can't even imagine. It must be the last Halloween trick that I'm going to receive this season. I mean, honestly, now that I think about it, it wouldn't be an infallible code stream if we didn't start off with a couple of problems.
yeah, our first example is live debugging. There we go.
Exactly. All right. Let me redo that intro since no one heard it. Jason, how's it going?
I'm doing well. How are you, Charles?
I'm doing better now because I really didn't think we were going to solve that. I was like, I mean, I can't wait to watch this back because by the grace of God, I was able to figure out that it was the tracks. Well, that's good. Glad you're doing well, and hopefully this doesn't set the tone for the stream.
Yeah.
Um, Welcome everyone to another Game Dev live stream. Today, Jason and I will be discussing self-documenting code.
hmm
Um, We've got the chat on, so at any time, if you have any questions, please feel free to drop them in the chat. We're going to try to keep an eye on that and address those as they come up. We're going to try to stay on topic as much as possible, although the first 15, 10, 20 minutes we'll be glad to answer any off-topic questions. Um, as always, I see a lot of familiar faces, so I'm not going to call anyone out because I always forget someone, so thank you all for being here. Who I will call out, however, are my patrons, my tier 3 patrons. I really appreciate all of my patrons and your support for the content on this channel. But my tier 3 patrons, you guys get a shout out, so I'll go ahead and do that now. I want to thank John Nix, Rob Homewood, DJ Weaver, Surav Chatterjee, Jennifer Irwin, Christian Urizer, Alwyn Kuravilla, Umit Surin, Dustin. I always mess this one up. Piatri Bungo, Nav from Academy of Games, Usuf Ali Castle, and Trond and R Star. Thank you guys. Really appreciate it. If I butchered any of your names, please drop a DM. Tier 3 gang, go. There's Tron. Hey, man. Thanks for your support. John says, stay on topic. Since when was that a part of these streams? I think we generally stay on. I mean, if the topic is programming and Unity and game development, we're always on topic.
Yeah, I like to think we always circle back. That's the important thing. Even if you go on a tangent, we always somehow make it back to the main topic.
Exactly. Pedro says, does deleting a zombie code on Halloween make you become a zombie? Evidently it does, although I survived. Someone always asks about Barles, or Barles isn't here, but non-zombie Charles is, and I survived. So kids never delete zombie code on Halloween, or you'll have to get an exorcist. I'm sure there's a joke in there, like a coding joke about getting exercised. So yeah, we're going to talk about all that. I hope you guys enjoyed the video. For those of you who don't know what he's referring to, last week we had a Halloween special where Barles and Charles uncovered some zombie code that needed to be deleted, but it had adverse effects, as zombie code often does.
hmm
Well, usually it's when you
But
uncomment it, not when you delete it.
well, yeah, or when it magically appears, as when you're working in a team with multiple people and stuff starts appearing in comments. But yeah,
Yeah. Peter, your wife made fun of you? Oh man. I'm glad. I know. I need to get Barles in chat for sure. That'd be pretty funny. Like I've been thinking about making a Twitter or like a Discord account
yeah, yeah.
to have Barles pop in every now and again. Um, yeah. So just I guess before we continue or really jump into the discussion, I always have housekeeping and things to bring up. So number one, of course, if you enjoy this content, please like and subscribe. It really goes a long way to obviously notifying the algorithm that you're enjoying this content, but also getting more eyeballs here and getting more people in the chat. And I think we always have really great chats. So yeah, it'd be nice to just get some more people in here. So like this video if you're enjoying it. After the video is done, if you have any questions or comments or concerns, or you just really enjoyed the content, please leave a comment on the video itself, the VOD. That's also super valuable. Another thing you may notice is that we now have merchandise. So I pinned one of my many, I guess, options here, and that's going to be a zombie code sticker. It also comes in t-shirt form and sweater and all sorts of other different product placement opportunities. You can grab that zombie code graphic on a mug and other things like that. And if you would like to support the channel, you could also grab the Infallible Code merch. I've got the icon logo and a light and dark version of my
I have the
logo.
pen. I like the pen. It's pretty cool. That's one of
Yeah.
my favorites.
Yeah, I really like the pin too. I'm glad you like it. I've always struggled with my logo. It just everyone knows we're all creators here. You know, you make something and you look at it and you're like, oh, is this garbage? But the pin looks really great. I like the pin. So, is it world shipping? I think so. It's through Teespring, and I'm pretty sure that they're equipped
Yeah,
to.
I think they did it worldwide. Yeah.
Yeah. So I'm also curious to know what you guys think about that zombie code design. I did not design that. I actually hired someone to do that on Fiverr. You know, can you really say that you hired someone on Fiverr? It sounds so official. I threw. It actually came out to more than $5. But I'm just curious to know what you guys think. So if you wanted to drop it in the chat or throw me an email. A couple of people have actually reached out to me on Discord and let me know what they think about the merch. So yeah, this is a first pass at it. Jason and
And
I.
keep in mind, right? It's our it's our community. It's not just like Charles' stuff. So if there's anything that comes to mind that would be cool, keep in mind it's stuff that we get to use and have and wear or whatever. So like, I have the Charles' pin as part of my collection of pins, just like this one. So any cool ideas, let us know. We'll add it to the roster.
Heck yeah, no, absolutely. I want the merch to be, something that we can all enjoy, and that's actually why I went and got that zombie code design created because I was thinking like I want a shirt that says zombie code. I think that'd be pretty funny. Like I don't have any good coding shirts, so yeah. See, we got a question here from Peter. I wanted to wait. Oh, he's talking about Zenject. I have a question about dependency injection. Oh, that's gonna lead us down a rabbit hole.
Yeah, I think we're gonna have to pause on that one.
Yeah.
So there's sort of a hierarchy of topics that start with vaguely around general clean code to what constitutes how you should design your code, up to how you should architect your code, up to methods of using tooling to architect your code, and so on. And like Zenject is 10 steps down that hierarchy. So we're kind of more at the earlier stages now. We're going to talk about sort of writing code that's clean and that's more for readability and in general self-documenting. So we're not going to get to that today, but we have covered dependency injection in other videos.
Yeah.
And there is various other resources for Zenject particularly, which is again renamed now to Extenject. So that will help for your research.
Yeah, and what we're going to be covering today, writing your code in a more readable way, self-documenting. It's kind of like writing testable code. It should set your code up in a way that you could use dependency injection in the future if you wanted to, as opposed to code that is responsible for grabbing its own dependencies and things like that. Typically, when you write code that's encapsulated or has a lot of indirection, you end up having constructors that take all the dependencies in. So that does kind of position you to use dependency injection. But yeah, it's just a topic that we don't want to go down a rabbit hole. it would
Plus,
be a whole...
we already have lots to cover in just the simple idea of basically naming things. So we'll get through this and we'll add it to the list.
Yeah. Appreciate the question.
So I guess we should probably start diving in, right?
Let's do it. No, you're totally fine, Peter. It wasn't out of topic. It's just that's just one topic that definitely deserves its own dedicated videos, and we have some.
Yeah.
All right, so let me switch on over to our screen view, and I see a lot of people mentioning things in the chat that we're definitely gonna to dive into. But so the topic of this whole stream, the discussion is writing self-documenting code. And this all stemmed from last week's video. If you haven't seen it, don't worry about it. You can check it out later. But the premise of that video was that Barles came across some comments, and Charles, I'm talking about myself in the third person here. I advised Barles to delete comments, even inline documentation, comments that are documenting. And so Barles, got up in arms with that. Obviously, it's like, well, how are we going to know what the code does? And, we'll go into that. But the main advice that Charles gave was, well, you can write self-documenting code. And a big part of writing self-documenting code is that you use a lot of indirection. You encapsulate a lot of your variables and things into classes and methods and properties. But we kept seeing a lot of, and this is, it's pretty obvious to think, well, if I'm adding more code, wouldn't that make my code run slower because there's just more that the compiler has to go through when you're running the code. There's more, there's more classes it needs to pull into memory, etc. So we wanted to just start the whole thing off before we give any tips, just talking about indirection and I guess kind of the effects that it already is taking on your code without you even knowing about it. You wanted to add anything to that, Jason?
No, I think you pretty much nailed it. The basic idea is there's a general fair perspective that every method, every time you do a getter or an accessor, or you're creating more classes, that you're adding more cruft, right? More layers between the stuff you're doing. Now, without getting into too much detail about the fact that if you think that there's already a disconnect, because the things that matter are not the classes and methods and whatever, it's the boxing and the garbage collection. That's the actual thing you need to care about. We're not actually going to cover those right now, but we're going to try to dispel a few myths about the way code works. Right. So I think this is a very good example to start with.
Especially in game development, where you think like, I need to have my code as lean as possible because this thing needs to be extremely optimized. If you're using an engine like Unity, a lot of that kind of goes out the window because they're already doing a lot of things under the covers for you.
So let's take this is, to me, is a fantastic example, because it's basically saying this is about as simple as you can get. Now, we could just write if transform is not equal to null, do X. Mm-hmm. And in this case, we're saying, well, what does is in the air mean? Now, that's already, we're doing a bit of self-documented code, but the general idea is if transform is not null and position is greater than certain one, it's in the air, that's fine. But the thing is, you might look at this and go, well, why do we need the is in the air property for this? Why don't we just write if transform not null and position in our update loop specifically? Well, yeah, actually, that's a good point. Might as well just demonstrate it as if it's in the air and then do some code.
Or if I did it the original way.
Yeah.
Like that.
So this is a pretty fair comment you hear. Like, you could just do this. Why do you need to go and split it up into this separate individual check? Well, it's not that you need to. It's that it's cleaner, and we'll get to that later. But the most important thing is, you might think that you're doing the simple thing, right? This is the simple one, right? None of this extra mess, extra functions. Well, let's take a look at the simplest line of code here. Transform not equal to null. What happens if we look into this code and see what it's doing? So if we dive into this one layer deep.
Just so everyone knows, in Writer, this is the IDE that I'm currently using. It's called Writer by JetBrains. You can look that up. You can use control, and if you mouse over anything, it'll allow you to click it and actually go into the implementation, dive down into the layers that are behind it. So if we click on this not equals, also just...
What does this one symbol mean? I love this bit.
There's a lot to unpack. I will also mention I'm using a font called Victor Mono, and this is what's called a ligature. Basically, this is just the same thing as not equal. It's just when you do not equal, the language or the font knows how to stylize it. Just, I know that those are going to come up in the comments. So
yeah, it's basically that's exclamation mark equals. It's nothing fancy.
It's nothing
it looks
fancy,
but it's the same as if you just written exclamation mark equals.
Right. So we'll go ahead and control click.
Yeah.
So
the first thing that might surprise you, if you've never seen this before, is that symbol is actually just an alias for a function call. And that function call is object.compare base objects. So that's what's being called when you actually do the exclamation mark equals. But we're not done. Let's go down one more layer into this.
So now we've gone down into compare base object.
Here we go. So now keep in mind, all we're doing at the moment is we're looking at the not equal symbol. We haven't even looked at code yet. We're just looking at not equals when you're on a transform. So does some flag checks. Then it's got another function call, is native object alive? And it does this twice, potentially. So we go down to that. Now we're checking if there's a cached pointer to the object. Now we're checking if it is a monobehavior or a scriptable object. And then it does a couple of things. And we're going to stop here because otherwise we'll just keep going down for a while. But the point is, for someone who says, why add this extra confusing / more performance cost layer of adding one function call? You're already doing this. You don't know this, that it's already happening. It just may feel cleaner to use not equals. But by the time you're using transform not equal to whatever, you're already calling like 4 methods and doing multiple checks and casts and whatever. And so it's not really a great argument to say, well, it must be bad for performance if I wrap this in one line of code. You know what I mean?
Right. Like someone would say, well, it's faster to just do it, to do it right there in line. It is in the air. This just adds, another layer. But yeah, there's already so many layers underneath.
But yeah, when you realize that it's not the difference between adding no layers and one layer, it's the difference between adding 5 layers and a 6th layer, then things are a little bit different. And
Now I don't need
for
this
context,
comment.
yeah, exactly, right. So now we'll get to some of that in a later bit. But so it's not just that. That's one thing I think is very interesting. So whenever someone says, why this extra layer of indirection, which is what that is, by the way, you're indirectly separating one line of code. Well, first of all, there isn't a cost to it. That's or at least not a appreciable cost. And one thing I probably would like to mention, just to give context, is remember that bit, the code I showed you before, the transform position one, Charles? Let's drop that inside the if in the air. If is in the air.
Which one was that?
So in after 13 inside the brackets.
Okay.
Just do transform that position. Oh no, not an if statement. Just a normal assignment. Transform that position plus equals a direction. So vector 3 dot forward or something.
All right, yeah, gotcha.
Yeah, that's fine. Yeah, and then multiply that by 5.
Oh,
which is
I
speed
remember
or whatever.
now.
Yeah.
Well, I mean, what was it, time dot delta dot 5 or something like that?
Yeah, that'll do. Yeah. So for people who are really worried about performance, here's an interesting thing. If you write this line versus copy it again and remove the brackets. So the difference between both of these lines vastly impacts your performance, far more than the difference of having 100 or 200 indirections of various functions and methods and calls. Because the difference here is what this does is it multiplies a vector by a float and then a vector by a float versus 2 floats and then that result by a vector. So this isn't about micro optimizations. That's not the point of this conversation. I'm only saying it to highlight. If the argument is you shouldn't use extra classes or extra methods because they might be bad for performance, then you're looking in the wrong place. There are far more potent optimizations you can do that will vastly improve the quality of your code and still let you have clean code. Like the argument that you shouldn't be using extra methods and functions because it might be bad for performance just doesn't hold up. It just really doesn't. We're not even done yet. That's just a couple of starting points. So.
Right. So now we'll head on over to dot peak.
Mm-hmm.
Okay.
Well, first we probably show it running
Fair
first
enough.
before we go into the So here's a second example. So we've now talked about methods and properties and how they're not really that bad for performance as people think they are. Well, let's have a look at classes. Right? Surely extra classes are bad for performance. So we can run this example. This is just a wave spawner. All it does is takes in a bunch of objects and should spawn them in counts. Yeah. So is this the Yep. So cube, and then
there we go.
sphere, and then I think at some stage it changes to capsules. There we go. So super exciting code.
Compelling.
So if we just look at it in the inspector, so click spawner in the inspector there, and we'll just have a look at just to show the how it looks in the hierarchy first. So
I'm sorry. Spawner inspector.
Yeah. So just to show here, it's an array of 3 elements. Each one is like cube times 3, sphere times 5, and capsule times 2. And that's what we just saw. And so have a look at the code of what it's doing. This is just a straightforward set of coroutines. So what we're going to do is on start, we'll spawn waves, which is after 0.5 seconds, spawn all the enemies with a 1 second delay between them. And then that's what it does. It waits a second for each enemy, spawn delay, spawn each enemy. So it's not a lot of code. If you actually zoom out, you'll see the whole thing pretty much fits on one little screen. It's not that much code. Yeah. And there's an enemy set object, which just contains the objects themselves. So this would be an example someone might say to me as, I don't need extra classes. Like this, I can fit all of my code here into this small little snippet of code under 100 lines, and I can spawn multiple waves of enemies with different counts, different delays. That's kind of a nice, powerful set of code, right?
Yeah.
Well, let's see what happens when we build and compile this project.
All right.
So let's have a look at what the decompiled version of this code looks like. So this is what happens when you compile this into a DLL and then you open the DLL and see what it looks like. So this looks about the same. There's a bit of extra plumbing and cruft based on how the compiler works, where it's casting objects back and forth. But it looks about the same, right? Nice and neat, just a couple of lines of code. The thing is, this is a lie. This is a...
Code is a lie.
The code is a lie. This is reconstituting it back into something that we can read that approximates what we wrote. This isn't what the compiled code looks like. Let's have a look at what actually is in the code as it's compiled into the DLL.
There you go.
Suddenly, it's an awful lot larger. This is what actually happens to that code that we wrote. So it's a little bit bigger than just a few lines. And if you look very carefully, you'll see that these are classes. So we can minimize a few of these here. And so this argument of I couldn't possibly add an extra class, it might cause too much problems with performance. Well, the compiler is adding classes for you. Just that one example has added 3 additional classes to the project. So the argument that adding an extra class might be some woeful, terrible thing for the performance is kind of silly when you realize in even this small example, all of these extra classes have been created for us. So again, I'm not going to say it's not like performance isn't something to completely hand wave away. Like there is a reason to care about performance, and these things are important. But to just hand wave away clean code must be bad because there's extra lines of it shows a misunderstanding of some of the actual steps of what's happening in the background. So there are certain things like the difference between structs and classes, which are important for performance. There are tons and tons of these extra little things to think about, but usually it's misdirected energy to say that you don't need a class here, you don't need a method here. And I think focusing on the value they add is more important than this supposed trade-off of, which realistically is about 500 of these might cost you a millisecond or so. Like it's not, it really isn't anything in the grand scheme of things. And that's why I gave that line earlier, the example of the transform dot position. If you found that line and changed it in your code, that will massively improve your performance far more than all of this indirection would. So again, it's more about focusing the energy on where the real value is.
Just another thing to mention too is like, we're not saying that this is bad. The fact that it added just 3 classes, that's fine. It's about a scale thing. It's just, if you look at this at scale, even 500 classes, and don't quote me on this, but even something like that at that degree isn't really going to have much of an impact on your game. So whether it's adding 3 classes behind the scene or whether you end up adding maybe 6 classes in order to make it easier to read and easier to maintain, those two, the benefits of the latter example is that now you have code that you can actually maintain over a longer period of time and actually implement more sophisticated behavior because it'll be easier, as opposed to when you have function that's all kind of, crammed into one mono behavior, for lack of a better way to describe it. That code is much more difficult to iterate on. And if you do end up iterating on it without ever, introducing more indirection or encapsulation, you end up with a very hard to read class that isn't really much more optimized than what you would have if you just made it, more readable.
Mm-hmm. And that's one of my favorite lines. The compiler is smarter than you. That's 100% true. Right down to there's some really clever stuff. Like it's actually kind of fun to take your code and decompile it and see what the compiler does. And there's often times where it'll do stuff that you didn't realize. Like you combined a load of strings at some point, it didn't pay attention. All of a sudden you open it and it's just written it in line as a constant, as all one string, going, I guess I never changed the variables at any point. And you wouldn't notice these things until the compiler sees it.
Yeah.
But yeah, another thing, somebody made a point of if adding 1 class is going to lead to 3 classes, isn't it bad to add the 1 class because it's going to add 3 more? Well, no, because I admit this is a little bit of a contrived example. It's specifically when you use coroutines or you use tasks in basically any code that's either designed to be asynchronous or parallel, because again, coroutines are not asynchronous, they're parallel, then the way that works in the background is a state machine. And so this example is specifically just about coroutines. So don't worry, not every class you make is not going to become 3 classes. I'm just pointing out that if you don't know how the underlying code works, there will be classes generated for you. So just saying classes are bad is a bad example, but this isn't going to happen every time. This is just a case of there are other things that will happen. My point is just that the compiler is going to be doing things to your code that's expanding it and changing it. And so designing your code to make that optimized is kind of a bit of a silly idea.
Yeah. So all that being said, hopefully that dispels the common and reasonable rebuttals to this sort of techniques that we're going to show off today, that doing all this is just going to make your code run slower. And we're talking about making games here. So obviously you'd want it to be the most optimized code. In this case, the optimizations that we can get are not going to be from making all the code live in one class. You're just not going to see any sort of improvement.
And so if all of that was confusing or over your head, or you're not familiar with either coroutines or any of the decompiling stuff, the only takeaway from all of this, you can ignore everything we just said for the most part. Just the highlight of all of that is just to say that the next stuff we do is not bad for performance. That's all that was, to demonstrate why it's not bad for performance. But if you didn't understand that, that's fine. That's the technical bit out of the way. We're going to now move into the actual practical applications of stuff you can do. So
Right.
it should be easier going forward.
Yes. Now, before we do that, I just felt like it would behoove me to talk about comments. I know that's not the focus of this, but that is what sort of started this conversation in my previous video. And I see that, a lot of people were mentioning that, comments are good. You get that inline documentation. In some cases, you might use summary tags and do like automated documentation. So I just figured that we would talk about that. And the first and the most obvious example that everyone can agree on is zombie code. If you don't know what zombie code is, get the shirt. No, I'm just kidding. If you don't know what zombie code is, essentially it's like when someone, let me pull up, switch back to the code real quick. It'd be like if I had some function that does something. So let's say whatever, do something. And I was using it at some point and I was like, okay, this is a great function. And then for whatever reason, I'm like, you know what? I'm not going to call this anymore. I rewrote some code. I have some other function, but I like this logic. Let's say there's some logic in here that I'm like, I don't want to get rid of it. So I'll just comment it out, leave it there. And what happens is, even just this one example of leaving this simple function in here, this can be very misleading in the long term, in the life of your project. Because if you do this even more than once, if this becomes a habit where you're like, I don't want to delete this logic, what happens is a couple things. Someone may come along later and look at this logic, this function, and say, oh, do something. That's interesting. I actually want to do something up here. Well, maybe I'll just uncomment it, and uncomment it, and I'll call it now. Some other developer who isn't even yourself might see that code and think, this is great. And you know what? Because the method name might be something very obvious that they think that they need, they might not even look at the code or understand the implications of that code to your system. So essentially, leaving zombie code is like leaving a mine in your code that could eventually cause some inadvertent outcome that you didn't expect. Because I might run...
Well, even as an example, like you can do this very succinctly by make a class at the bottom, something just like, some
Right.
public class something. So this is a common occurrence, right?
Something.
So you'll just do any something. So you have this class that you're referencing because you had this idea that you're going to build this connected system, and this has some things in it, and you're using it for something. And then you go all the way up to your method, and in the middle of your other method, you were using this object because that was the point of that object, right? So in the logic here, you were referencing this, something object. So yeah, you're doing some work here and it's creating something. And then you change your mind later and then you comment out this line of code.
Right, so I'm like, screw this code.
Yeah, I don't need that anymore. I need to delete the reference. So now later on, you scroll down and you're working on your project and you realize this grayed out something here is, I'm not using this for anything. So you delete this class because you're not using it. And now we're back at that original stage where someone's scrolling through the code and says, oh, this does that thing I need. Let's uncomment it. Hang on a second. It's referencing stuff that doesn't exist anymore. Because what happens is, as your code changes and refactors, those older comments are now lies. They reference things that don't exist.
Yeah.
They're not in the world anymore. And so in general, commented out code is something that is always going to be out of date, because by design, it is an older version that you're not using because you don't need it right now, but you're keeping it in the code because you're kind of assuming you might need to possibly look back. Maybe there's an algorithm in there. You can't quite remember how to rotate things a certain way. So you keep it in the code just in case you have to come back to find it. And then you're going to cause yourself problems like this.
So then you might say, well, I want that code. What do I do? Do I copy it and paste it into a Google Doc or something?
That was one of the comments. Copy it out and then save it. And it's like, I wouldn't do that either.
Here's what you would do. You would generally use source control, right? And so I think this is something that maybe a lot of people haven't really considered, but you don't need to save source control for a project where you work with a team or that you're working for a job. You can use source control locally for a project that may never even see the light of day. You could use source control for your own project and never even push it to a remote repository. And in Writer, it's as simple as going to the VCS tab, saying enable version control integration, and you just choose whatever you want. I only have Git, so I hit OK. And now it's going to do its thing, and now I have Git enabled in this project. Of course, I can do some other things like, set up a Git ignore, blah, blah, blah. But in this case, I could literally have my let me undo this. I could have my do something method here, and I could just commit it. I could just write a commit message, then commit that code, and then delete it, and then write another commit message. And now I have access to that whole history locally, and you never even have to push it to a remote repository.
Yeah. So in short, your code is, so what is the point of code, right? Code is you're writing instructions to complete or solve some problem. And having notes in the middle of it is kind of weird because the point of the code is to be the instructions. If you have to write instructions to explain the instructions, something is wrong. So the idea is this commented out code, it's not valid anymore, right? So just get rid of it. There's a great quote from Bob Martin who says he doesn't even look at comments. If he sees a commented out chunk of code, he will just delete it because it's either something someone else had that they want from a different problem. If it's related to the problem he's solving, it might be referencing things that don't exist. So there's zero chance it'll be of value to him because it's either not related to what he's doing at the moment or it's outdated. And in either case, it's better to just delete it and start from scratch. And so I would say, though, to be fair to a counterpoint, because I'm not as regimented as that, is I will say that a problem I have, and I think a lot of people will with Unity, is sometimes you just forget a line. For example, there's a particular, like a nice rotation code. There's like, this does a really smooth rotation. I like that piece of code. Or here's a good bit of, how do I interpolate between these two values? Or how do I, get the 20th percentage element from this array, or some piece of code that you like. And you might be tempted to just leave it commented out inside of your code. Well, for me, I just use something like Pastebin or gists on GitHub. And just, so you don't have to get rid of these little snippets that are valuable, but if they're so valuable that you want to keep them, putting them in a comment arbitrarily in some class is not a good place to store them. So if that's your argument, that you might need this piece of code at some point, make a dedicated place to put snippets of code you like and put them there. And that way you'll have a nice way to search and find them without like randomly muddying up your code base.
I'm sure they have this in Visual Studio, but it's built into Writer where you can right click and say create gist. And then right there, you've created the whole class. You can drop in there if you want. That's a really good example. I know that source control can be kind of overwhelming to some developers who aren't used to using it. I would recommend getting used to using it and learning it. But in the meantime, a gist is certainly a nice place, especially if it is a piece of code that's pretty generic and something that you might want to reuse in other projects. Just build a library of your own, gist. It's pretty nice, and you can even end up sharing that library if you have enough stuff in there.
And a lot of people joke about Unity collab being terrible, but it really isn't. Like I use it on a lot of projects and it's perfectly fine. So if the whole Git process and writing Git ignores seems like a lot of overwhelming work, there's that button in the top right corner, it's a little drop down button inside of Unity. And if you hit that, you can switch your project into collab mode.
Mm-hmm.
And collab just lets you commit your project and you commit it. So yeah, that
this one right here, right?
Yeah, right there. Yeah, and you say, so you have to go through the whole thing. Set the project ID, click next, and once you're done, it just gives you a nice little drop down, and it'll let you commit your project. And then all the source code's managed for you. You can always roll back to previous versions. You can see changes. You can have multiple people work on it. That's a really short and easy way to have the project maintained. So again, once you know your project is maintained, you don't need to maintain these snippets in the middle of your code. You can always roll back to older versions where you did it a different way.
Yeah, definitely. And I see that someone recommended using Notepad++. There's like I guess you can use some sort of extension there. There are so many different ways. The most important thing is you find whatever workflow works best for you. For instance, Collab is great. I don't ever use it because I have years of experience with Git, and I've just spent so much of my career trying to learn the ins and outs of Git and rebasing and all that. So I live in Git world, and that's fine. But if your team uses another product or you're not familiar with Git, you can use whatever you need to use.
And in my case, I use Pastebin because I share code snippets a lot. I get asked a lot of questions about stuff. So I find that's a really handy way to share and pass them around. And it's got a nice search function. And so that's what I use. But you don't have to use one or the other. Just pick the thing that works for you.
All right, so moving on from zombie code, the next example would probably be something like inline documentation. So this function spawns waves. You could say something like that. Or you might even say, this is a coroutine, right? You want to give as much information as possible. A coroutine that spawns waves. Of what? Of enemies. Look at this. As I write this comment, I'm already finding myself thinking like, well, if I'm going to write the comment, I might as well write it correctly. So one thing that could happen is you could either take the lazy route and be like, maybe you write wave spawner, whatever. Okay. That's not very descriptive. You might know what that means, but someone else might not. And then you might get more descriptive and say, okay, well, let me make sure I say, well, this is a coroutine. It spawns waves of what? Of enemies. Okay. But if you even want to take it a level further, you might even be like, shoot, I really need to, if I'm going to do this, I might as well do this right. You say, okay, well, enemies is a list of of enemy sets. I'm
Yeah,
not
with
even
a start delay and a spawn. Yeah, you can
yeah,
go to the whole thing.
I won't even do it, but you get the idea. Like some people, rightfully so, might be like, well, if I'm going to comment this, I really should comment this.
And another one of these people will put examples like example, given this number, it'll come
Uh-huh.
out this number, or given this function, it'll come out this function. And there's a surprising dangerous thing you've done there. It may look like you're just writing a casual comment, but you've actually done something far worse, which is you have described the exact implementation of how the functionality works. You have said this line of code with this name promises to do this way with this thing with this result, which means if you change any of those things in the actual code, will you remember to change that in the comment? Or will the comment now be literally lying? Will it be wrong relative to
We'll
what the
talk
stuff
about
is
this
doing?
later. Hold on. Yeah,
Yeah,
exactly.
yeah.
I'll talk about that's we have a point on that. Yeah, exactly. That's a good point that you make. Like it's a promise. You're writing that down. You're saying this is what it does. But what you would find after years of doing development is that comments generally lie about what they do because developers don't generally update them to correspond with changes. And
Mm-hmm.
I'm not even saying that as a bad thing. Like when you're in a crunch period and you're trying to push out features and you got release in a couple weeks or whatever, you're not concerned about the comments. You're so worried about just getting the thing to work that it's very common for comments not to get updated. Or I mean, I hate to say it, but you might be a very fastidious person like I am. I'll leave a comment and I'll be the one who like goes into great detail. But if some other developer comes along who's on your team who is just like, nah, I'm not doing that, then they're just not going to update it. And you may not even know it. They might just change the code and you will even come back to your own function and maybe forget about it and say, oh, thank God I left a comment there. Now I know what it does. Little do you know, someone came over top of you and changed, the implementation. So those are the
Mm-hmm.
hazards of comments.
And the other thing to keep in mind too is it's something you brought up in the video actually, which is a great argument, which is if you write a comment that says, here is my code that spawns waves. So first of all, you write this code that spawns waves. And again, what is it? This is instructions, right? This is the code itself is literally a step-by-step guide of your intent. So that's what I always say. Code is intent. It is, I want the system to do this. And you were describing it to the computer to a certain degree and writing what you want to happen. If you write a comment, you're writing it twice. You are saying, I want this code to spawn waves at this interval with this time. And then you write a comment on top of that that says, by the way, this code spawns waves at this interval at this time. And the question is, who is this code for? And again, I've said this one before too. It may seem like you're writing the code to talk to the computer. You're not, as we've demonstrated earlier with the decompiled code, which then goes into IL, which is a whole different thing we've discussed before again, is the code you write is not for the computer. If it was for the computer, you would be writing in IL or you'd be writing the actual, procedures out yourself. But you're not. You're writing in a language that is easy for you and people you work with to read. So the code is for programmers. That's the answer. The code that you are writing is being written for programmers, mostly you, to read and understand. And so if you've written out the code in a language, aka code, that coders understand, why would you then need to write the same thing out again in English or whatever other language for your programmers to understand, when by design the code is for programmers to understand?
I'm gonna pull out my favorite quote here on the screen. This is my favorite Martin Fowler quote. Any fool can write code that a computer can understand. Good programmers write codes that humans can understand.
Yeah.
I mean, it's pretty succinct right there. I mean, you really want this to be human readable as much as possible.
So that's kind of the entire ethos between this whole stream, which is if you are good enough at writing your code so that it is readable and understandable to fellow programmers, you don't need comments. Comments are there to explain whenever you failed at describing yourself correctly. And I think that was, again, Bob Martin has a similar quote with that, which is, if you're writing comments, it's because you failed. You've been unable to explain in the code what you intend to do, that you've given up and had to write a paragraph or some text to explain what the code is doing. If the code is well written enough, it should explain itself what it's doing.
Yes. Now, that being said, there are occasions where comments are acceptable. I mean, I don't know if that's the right word, but which are generally accepted among developers. Before we get into that, I noticed that people were talking about the triple slash. So if I go slash, it's going to do this whole summary thing. And what this does
The XML comments.
Yeah. This allows me to, again, comment what this does, and it gives me all these fields for what the parameters are, etc. Now, this is valuable. Why? Because it allows you to automate the creation of documentation. But you have to ask yourself, why do you need to document this code? Well, if this is for a project where the code will never be reused, it's just literally doing its job in the context of your game or your project, there is no need for documentation for that code. Where you really want to document code is if you're writing a library or an API, something that will be consumed by an audience of individuals who won't actually have access to your code. That's the important thing. So let's say that I were to use a library like a good example is what's DoTween. DotTween or DoTween? I always forget if I say that right.
I call it DoTween.
All right, so DoTween is a great tweening library for Unity. You should definitely check it out if you haven't used it. And that developer went to great lengths to make sure that all the code was documented, right? And so I could imagine that he potentially used something like this to automate that. Well, that's great because I wouldn't necessarily have access to the DoTween code if it was in a DLL or something and I just couldn't see it. Obviously, there's decompilers and things like that, but I'm just talking about I'm a developer who's trying to use a tweening library, and I don't want to have to sift in the code to understand what it does. That is where something like this is valuable. In this wave spawner lives in the context of this particular project, and I'm never going to take it out of this project. So there's really no reason for me to go to the trouble of documenting it. And the thing about libraries too, and just because some people might bring up the fact that, oh, well, if it's a library, isn't it the same thing? I'm doing all the work twice. If I make a change, I have to update the comment too. Well, yes, that's actually important because with libraries, you don't want it to change. Because once you release that library into the wild, you don't want to make deprecating changes that are going to mess up developers who use it, or else no one's going to want to use your library. So
that's why there's literally a deprecation tag as well for certain comments.
Literally baked into the code is the deprecation tag. So yeah, just to say that this / thing, I would never recommend using it on your own project. If you're writing a library that you expect users to use and you want them to be happy, yes, you would use this. But otherwise, yeah.
And even then, I would say that's maybe it's a personal thing. I would even push back on that in certain cases, purely that I don't do that simply because. So I write those comments in one case and one case only. It's when I'm writing a literal web API because I use a tool called Swagger, which is a tool generation of Swagger is the platform, and then Swagger Docs is the doc generator. But effectively, it generates a nice web page, which lets you test and run an entire API without an application at all. You can just run it directly from a web page. That sort of stuff is really valuable for the documentation. But again, I want to be very cautious about something. Even when you do comment things for the sake of an API, there is a point where it's valuable and there's a point where it's not. And something that I see a lot, and it drives me absolutely insane, is, so for example, do a property there, Charles, called name. Or age, actually, because name already is one to avoid into age, yeah. So yeah, so this would be something you'd see as a standard property in someone's API somewhere. And pop a comment over it.
Oh yeah.
Just your yeah.
/ or just anything.
/ yeah. And then just call it age or the age or something. So I see this surprisingly often. Exactly, right? And it's so pointless because if you see something called age, this doesn't need expansion, right? The point of comments is to add extra value and extra information. And I say this a lot with all names. Every character you add in your code is designed to add some information. And if the word doesn't add information, then there's no point in adding it. Take a look at all of the code here. Start delay, what is it? It's the delay of the start. What is a wave? It's the wave. What is the wait for seconds? If that was wait for, it wouldn't make any sense. If it was 4 seconds, it wouldn't make any sense. Every word adds some value. And there's a problem with comments where stuff like this, all it does is add extra noise and mess. But so if you're commenting your API, it does seem like a great idea to comment everything rigorously. But keep in mind, if people are opening your code to edit it or change it, or to figure out what it's doing, it's far more valuable to see examples of it working than it is to sort of scrub through the documentation. So my one argument is I'm not saying don't do comments when you're giving people a API or a library to work with. I'm saying ask yourself if this comment is helping to understand something. So personally, I prefer having external documentation that explains what the goal and the relationship between the elements are.
Mm-hmm.
I like to have example libraries, which give examples of use cases of where it works. And then the code, which is mostly self-documenting with comments on certain algorithms or certain values you want to keep in range. And finally, if things should only stay within certain values, basically never put this greater than 500, or the correct number for this is somewhere between 20 and 50, you could write a comment to explain that, or you could put a clause in there to stop that from ever going out of range. So
Right.
a lot of comments should really only be there if you genuinely think someone should be confused about what's going on. And honestly, I think if you're giving someone an API to work with, you are more likely to help them by giving them a project they can run where they can press play and it works and they can open it and see the 3 lines of code you need and what it does, rather than giving them really detailed comments and then having to figure it out themselves. So it's down to personal preference, but I do think that comments, more often than not, all they do is bloat the size of the file and add noise, because people tend to write something that should be readable in the code they're writing.
Now, that being said, I think from my own personal experience, I'm sure you have experienced some things like this. I find there are a couple cases where comments are useful. And in one case, I think regex is a great example.
Oh, yeah, what it references. That's a perfect example of what does this actually evaluate.
This evaluates a phone number, whatever the case may be. And of course, you might even name it like phone number pattern or whatever. But, there are some cases where you inline a regex expression. And, and that's totally fine. I think there are cases where you can add some detail about this. Another example is if you have a comment. So, if you have a comment. If you have found an obscure solution on Stack Overflow. So let's say I copy and paste some solution from Stack Overflow, which is totally fine. I'm literally just copying. I don't even know what this does. Let me see. This is... Right, so this is some file reader or whatever. I might be like, look, this opens up a file and it does some obscure thing to the directory, whatever. I'm just gonna say, boom, paste in the actual Stack Overflow, and I might even put a little description of like, this solution does some obscure thing. And a lot of the times, I wouldn't recommend doing this, but in a situation that I've seen this really valuable is when I'm in a crunch and I'm like, we're working on a release candidate and we're trying to get this product out the door or whatever, and I find some obscure solution that works. I will drop it in and push it and say, look, this is it. We're obviously going to need to look at this later and try to understand what this is, but in certain situations, I've found this to be useful. I'm not sure how you feel about that, Jason. I imagine you would.
No, I hate those. Yeah. See, my reasoning there is, if you're pasting code in and you're saying, I don't understand this well enough to use it right now, or I'm using it, but I'm not really figuring out how it works. Well, I understand that's a problem. You're trying to go fast. But what you're doing is you're saying, I'm just going to put this landmine right here and I'll come back to this problem later. And I think you right now, so here's my argument to that would be, you've just pasted some confusing piece of code into the middle of your project that you only half understand. You understand it enough to know how it works, but you don't understand it enough to really explain it.
Right.
Well, are you going to understand it more in 3 weeks when you come across it again? Or are you at the peak amount of understanding right now? I would say at this very moment where you know it enough to kind of use it, you're at the most amount of understanding you're ever going to have at the moment. So if you just do your best to understand it as best you can now, you are doing yourself far more of a service to take the extra time, as much as it may pain you, to pause whatever you're working on to fix it, than it is to leave it there and let yourself forget it later and then come back to it and then have to reread the article, reread the code, re-understand what it was doing, and then try to fix it if you ever do that, which we all know you won't because you're going to skip over it later. So what I would do instead is I have a knowledge base of various links and references and stuff related to my project. I will paste that knowledge base in there, that I will then speed through the project with the code with no comments, and I'll come back in later and I will then, when I'm having my breakfast, reread the article, maybe do a sample project on the side in my free time, and then come back to it and fix it when I can. So I understand it's not an ideal scenario, but I don't think saying, here is some code that doesn't work and here is some homework to do, bye-bye, I'll see you in a few weeks. I think that's doing more harm to your code base than good. So
well, that's fair enough. Fair enough. Yeah. I mean, I think it's a valid case. I mean, personally, if I haven't experienced something like that multiple times and it's been good for me, then I wouldn't have even brought it up. But I get your side, and I understand people are saying in the comment too that's like, you'll never go back. And that's a fair argument, you know, and I think it's a fair assumption. Just like comments, where I'm like, I will immediately not trust this comment if it's like inline documentation. I think it's a fair assessment to say, like, if it goes into production, it'll be there forever. I'm totally on board with that. I agree.
Plus, even the argument, even if it's like, I'm putting this here to go fast, if that's the argument, if I'm in a hurry, I need to put this here. What happens when in the reverse of this scenario, where you've been asked to add a new feature to an old code base, and you open a file and it's got comments and links to Wikipedia articles or whatever, and you're like, oh no, whatever estimation you just gave your boss on how long it would take to add that feature has just tripled. So all you've done is save yourself time and given it to the next person who now has to go on a homework spree before they add whatever feature they've found. So I see, that's like I said, it's a landmine.
It's a landmine.
You're choosing not to step on it yourself. I don't see that as valuable.
Well, that brings me to the next thing of things that I'll never come back to are to-do comments. And I think you've already talked about this, Jason, how you generally don't like this, but you know, I do appreciate that in most modern IDEs, if you put a to-do, it'll allow you to find a list of these to-dos in a dedicated window. So if there was ever a middle ground or a compromise, I think this might, you know, be it.
And again, I would say that was fine in the same way that it made sense to use various different prefixes in the past. But the problem with to-do comments is you're using to-do comments to say, I need to do this later, and you're placing it arbitrarily in the middle of your code, versus we live in a world where if you're online and you're using your computer, just open up a Trello board. And now you can write all of your to-dos in there and add images and add references and add all sorts of notes you want, and it's not going to mess with your code.
Right.
And if you're saying, but that doesn't link to the exact place in the code where I need to do this, that, or the other, well, good, because the question of I need to add this feature is not I need to add this feature in this place at this line of code. That's not what that means. You may come across it later and revisit how you plan to approach it, or you may change something. You shouldn't have to mark a line of code as the place where a thing happens, because that's not how code works. It'll refactor, it'll change. Yeah. So I think it's far more valuable to make a list of to-do items, which is, again, agile boards and blah, 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 a whole different conversation. But that's what that's for. This to-do concept was valuable when you didn't have the entire power of the internet and chat messaging systems and shared code and collaboration and all the other amazing things we have that you don't need to write to-do comments in the middle of your code. Code is code. It should do what it does, and it shouldn't have to describe what it does, and it certainly shouldn't have to describe what hypothetically might go here later, because all to do is saying is this code doesn't exist. It probably should. Like, what? How, that doesn't help anybody, because again, it's either for you, and again, you can manage it yourself somewhere else, or you're writing it to give someone else homework to do. And that's just like, what are they going to do? They're going to open up your code and then see it to do and go, oh, I'm going to stop what I'm doing and work on his to-do list item. That's just not going to happen. Yeah. So I think it's far more valuable to treat your code as the clean golden copy, write your notes in a to-do task. And this is without a whole separate conversation, which is priority. So anybody who's ever written an agile board or put notes on an agile board has noticed you will have a perception of what the priority of your tasks are. Right. You will say, step 1, persistence. I need a database. I need storage. I need this. Then I need to create the logic for this. Then I need to create the UI. And then you'll work on the project for 3 weeks or a month or whatever. And you'll be like, actually, you know what? I've decided I don't need that kind of health bar. We're not going to design that. Or, you know what? We're not going to use this database anymore. Or actually, we were going to use, we're going to write our own high score system. We're going to use the Steam high score scoreboard system instead. And then all of your tasks, the order is different. Some of them don't exist anymore. All of that changes. And so writing a to-do list to say do X, when not only will X maybe not happen, but you might completely drop it off the list, or you might change it completely. I just don't think to do in code is a good place to put it. Yes. So
I agree with you completely. I'm done playing devil's advocate, and commenting is not the hill I'm going to die on. So let's move on. I agree. I hate comments. Those are some cases that, you know, don't leave comments. Let's just leave it at that. If you're leaving a comment, think about it very deeply and ask everyone you know if they think that you should leave that comment there.
And I will say the one caveat that I will comment, which is the one time I will do it, is when I'm using a constant value that is something that I don't expect. So to be more specific, it's down to the knowledge base you're in. Mm-hmm. If I'm a programmer, I expect people who read my code to be programmers. Right. If I'm writing code that is a physics engine or that does physics stuff, I don't expect implicitly every programmer is going to understand, you know, the constant for gravity or the constant for this, that, or the other. Right. And so if it's a constant, I will name it that thing. But if that has extra information about it, I may put annotations or notes to say this represents X value when in this particular, this viscosity on this thing, or this is the particular surface tension of these kinds of things may require annotations, because someone might come along and say, why has he got this thing called, this constant friction of whatever, and what is it? Why can't I change that number? It might be valuable to say, this is real world gravity, this is real world whatever,
Right.
That's valuable information, because again, every comment, every word in your code should mean something. It should add value. And that's something that, that one scenario for me is very valuable, because I don't know a lot of these physics constants. So I need help when I read code to know what it is I'm looking at,
Yeah, for sure. All right, so we've pretty much gone over comments, and I think it's safe to say, you should avoid them. You should definitely avoid them. Now, what do you do when you need to write code?
If you can't use comments, what do you do?
What do you do? Right. So now, let's dive into, I think, this item painter example. Yeah, talk about what we can do. So here we have a class, and with a simple update method, and I'll show you what it does. But essentially, this is fine. This code is fine. It does its job. Let's go take a look at what it does. So I'm going to go over to my painting example real quick. Okay, so we have this painter in the scene here. It's got item painter. You'll see that there's two of them, but ignore that second one. That's going to be the refactored version. But essentially, it has an item that you would paint, which is this tree. So we'll go ahead and run
programmer tree, by the way. This is a programmer tree.
Programmer art, my favorite. That'd be a pretty funny shirt design. Like, it'll say programmer art, and it's just like some tree made out of primitive objects.
Yeah. Well, this is a pretty primitive tree. It looks like a horrible lollipop. There we go.
Ooh, yeah. Look at that. Holy heck.
There we go.
That's a horrible lollipop.
Yeah.
So essentially, I'm just hitting spacebar over some point on this.
And if you do it outside of the range, it won't let you paint, because there's nothing there, and there's no exceptions or anything. So it just paints on surfaces. So paints the surface, spawns an object.
Yeah. All right. So let's take a look at the code. You want to walk them through that?
Yeah. So this is in kind of the simplest terms in Unity. How do you basically paint onto a surface and spawn an object on that surface? And so if you'd seen this code, so imagine the context I want to give here is that it's very easy with these simple examples to talk about them as if they're simple examples. But imagine this is a project with thousands of lines of code, lots of stuff going on, and you see this thing called item painter, and you open it, and someone says quickly, as fast as you can, what does this code do? You'll have to read through it and understand it. So we're going to start at the left here. We're going to say, okay, raycast hit variable, whatever. Next, we're going to say if physics.raycast. So we're doing a raycast. That's step one. Camera.main. So we're doing a raycast, and we're referencing a camera, what on the camera, screen point array. So we're referencing we're creating an array from a screen point from the camera, and we're using the mouse position. And so, long story short, we are raycasting from the mouse position through the camera and checking if it hits something. That's what that line does. Then once we check that, we say if someone presses the key down space, we instantiate an object and place it on the point position. So now you can do that pretty fast. So I'm kind of doing it very verbally, but realistically, you can read that and you'll go back and forth and you'll figure it out. But be very clear here. Even in your own head, when you think about it, you are bouncing back and forth. You're going to read physics.raycast. We're doing a raycast. What's next? Camera.main. That doesn't mean anything yet. Camera.main, that screen point. Okay, now back to the raycast. Okay, we're raycast, but you're bouncing back and forth to understand what that line does. It's not a lot of time, but it's called cognitive load. It's a small bit of time because you're having to mentally store the variables of what this code does, repackage it, and then understand. And then you're going to turn that into your head as, oh, I get it. I am raycasting to a surface, or I am checking if the surface was hit. That's probably what this does. It's checking if the surface was hit. You're going to build that sentence in your head about what it does.
Yeah.
It's not that hard, but it's hard enough that it's a small bit of extra labor. And if you have thousands of lines and you have to do this in every line, that's more mental work to be done.
And you don't want to take for granted that you might be working on a team of people who maybe aren't familiar with Unity's ecosystem. Like if you're a Unity developer, you look at this and you pretty much know, like it's up, you've done it. But if you want to empower other developers to help you work on a project, you can't make any assumptions about what they're familiar with in the framework.
Yeah, great example. If you said to somebody, oh, hey, we want to do this thing where you fire a laser. We're building an evil robot and he's going to fire a laser at the ground whenever he sees an enemy or something. It's like, just go reuse the raycasting code from the item painter because it does the same thing. It paints to the surface. And they could look at it and go, oh, I've never used screen point array before. So they're going to have to read this and figure out which is the portion they need to care about. So that's step one. And then 2 is the input. And then 3 is the instantiate. And so the point is, this is fine. If this is the code you need, this is perfectly fine. It works. There is nothing wrong with it. But it's slightly confusing to understand. And more importantly, here's the big problem with it. This is falling into the category of being destructive. So by the way, there isn't. I did it in that order arbitrarily. You could do the input check before the raycast check. I'm doing it this way because in an ideal scenario, you would show an indicator, and the indicator would change its state relative to whether or not you're over or on a surface before you do the input. But that's a whole different conversation. It's just, if you were doing this the right way, you would raycast so you can give yourself visual feedback before you do the input check. But that's a whole thing. Anyway, where is that? Yeah, so the point is, that's the raycast, that's the input. Oh yeah, if you come along later and your goal is, right, we were doing a raycast from the camera, we've now changed it so it's like a claw arm or something, or an object that's moving, or it's actually first person now. We're going to be looking at objects to spawn them. So the line you're going to be changing is what the ray is. So the specific portion of this code to change to make this go from mouse position to first person is from the word camera all the way to the word mouse position bracket. So it's kind of that section vaguely in the middle.
Yeah.
And that is a little confusing. It's not super confusing, again, if you've done this before, but if you're not familiar with these moving parts, or you've got multiple people on it, you would have to change everything from inside that bracket to that bracket and put in something else. In this case, something like new ray transform .position, transform .forward, or something like that.
Right.
And the thing is, that is now a destructive change. So that old feature is gone, this new feature's in. Again, not the end of the world, but if someone then comes along and says, you know what, this whole raycasting in first person, it was a cool experiment, I like the old way better. So you now have to go back to your source control and pull back the old version or figure something out, or whatever.
Uncomment it.
What if they say, actually, yeah, it's like, oh, actually, you know what, we don't like the raycasting first person for this one, but this other enemy, he's going to do it in first person. You're like, oh god, so now I have to go and rewrite it again, or find another older version and backtrack. It's all sorts of mess, because this is the kind of code that will change a lot. It comes down to what collaborators you're using. So in this case, how many responsibilities does this tiny chunk of code have? Well, it deals with checking for the surface. It deals with mouse position input stuff. It deals with which input action, in this case, spacebar, performs the painting portion you're doing. And it deals with instantiating objects themselves. So there are 4 different things that can independently decide to change about this code. Completely unrelated. What if we're spawning different items? What if it's a random item spawner? What if we're spawning to multiple surfaces at once? What if we're so many little things can change that will fundamentally change this code. So again, little asterisks, we're not saying write any of this in now if you don't need it. But as this code starts to evolve, things about it will change.
Right.
So this is fine if this is all you need. But as you start moving into more and more code, hacking this code is not the solution, because you're going to end up having to hack and then unhack and then rehack and then double stuff and then paste it and copy and paste it and then do if statements, and it'll start to grow immensely.
Yeah, and it's like a case of every raindrop says it didn't contribute to the flood. Every little hack you do, it's just eventually you're going to get to a point where you can't go back.
Pretty much. And so here's an alternate way of looking at this code. This is an item painter 1, but here's another version that does exactly the same thing. So let's go to the update loop here and just ask a quick question. So same thing. Let's do the cognitive load test. You've got a project with thousands of different scripts. You don't know what they're all doing. What does this code do? Well, it checks a surface. If a surface is found and you've pressed paint, whatever that is, you spawn something at the position of the surface. Now, how much backtracking and reversing and double thinking do you have to do to understand that? I would like to assume little to none.
Right, and just to stress that, you'd be looking at this code in the context of, oh, I need to make a change, I need to add a feature. So if you were to look at this code and say, oh, I need to add a feature, I need to change the way something happens, or an example, I need to change what key is pressed, you have to find it in here. Here, it's like, you don't even have to change this code. If you change what key gets pressed that causes paint, you need to find out whatever this is and just go and update whatever that outputs.
So the main thing is that, 1, we've managed to basically describe what the code is doing. So the argument of, if you go back to the other one again, the item painter, this would be something where there's a good candidate to say, if you don't know what physics.raycast does, if you don't know what camera.main does, if you don't know what screen point array does, if you don't know what input.mouse position, where it's getting that from, you might have to comment these things, right?
Yeah.
And so the argument might be that you'd have to explain some of the logic because people may not know how to do raycasts or whatever. But if you go to the second item painter example, in theory, you
all
shouldn't
there.
need to comment this. Like the code is self-describing. Like it should make sense to what it's doing.
Yeah.
Now you
I
might
try
be
to
wondering,
correlate the comments just to
yeah,
show that, like, okay, if this first one here, it checks the surface and if it's found. So checks the surface and if it's found, then checks to see if the paint key is pressed. Well, we have that here if it's pressed, and then spawns the item. We have spawner.spawn.
mhm,
And I should say
yeah,
on, you'd have to say on surface because it's baked into this call. Where is it? Oh, the hit dot point. What the heck is hit dot point? Well, that's the surface.
hmm
Yeah.
so that's the first thing, is that this may seem so subtle. It's like, what are you doing? Oh, we just wrapped it in a method or wrapped it in a class. And it may seem like a quick hand wave of like, well, it's the same thing. We just moved it. Exactly. Now there's more implication. We'll just start talking about architecture. But the first thing to note here is by just even doing something as simple as naming it, we've already removed a couple of problems. We've, one, made it easier to read and understand.
Mm-hmm.
And two, here's the other thing, we've made it easier to change. So if I take line 23, if the surface is found and you've pressed the paint key, well, what does surface found mean? In this case, we know from the other example, from the item painter, it does physics.raycast. Blah 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 blah. But here's the thing: you go back to item painter there, the simpler version. Now, this is one particular overload of the physics.raycast function. We decide later, hang on a second, right now we're raycasting against every single surface. We actually don't want that. We only want to raycast against a particular layer. Let's say we're going to raycast against the ground layer, the dedicated ground layer. So for this, add an extra comma there, Charles. I think it's after hit. I don't even remember the order of these. Yeah, layer
mask.
Layer mask. Yeah, just layer mask, and then you can put in a number or whatever. We'll just pretend we know it by number. There's layer masks up from name or something like that, or whatever. Yeah.
Name to layer.
Name to layer. There you go. And then
now you got a magic string
round,
here.
Yeah. So that's fine. That's just you now extending the functionality, which is great. Our item painter now doesn't just raycast to the surface and paint. It now raycasts to the surface and paint only if it is the ground layer. But let's go back to that original thing of cognitive load. Now we have to read what that line does, and also, and it's doing layer name, dot name, and so on and so forth. And you can move this out and all sorts of different things, but functionally the problem is still there. Now the check surface isn't what that line does anymore. The comment is now out of date. It is check surface to see if it is ground. So would you have remembered to change that? And even if you did, what if you change it from ground later to ground and slopes of certain angles, or so on and so forth?
Like, let's do the hit layer. I don't know. We call it hit layer, something like that. Yeah. Now it's like, what the heck? I gotta update this. And then you're like, what the heck is the hit layer? Like,
so there's already, like, this is starting to grow slowly but surely. And that's one feature. What if you want to hit certain layers and have a delay on it at certain times? Or what if when we start spawning objects, we want to animate them when they appear? All sorts of different little details that you want to do later are just going to keep making this messier. Mm-hmm. But head back to the item painter. Yep, sorry, the other one.
Oh.
Yeah. I did it from today. So now here's the subtle thing. I'm not saying we don't have to do the exact same code. We do. We're going to have to also write the layer mask portion into this code. But here's the thing. We don't have to write it here, because all of that reasoning about whether or not something is on the right layer, or if it's grounded, or if it's surface detected, is boiled down to the sentence surface.found. And we don't care what surface.found means. It could be hit the normal ground, hit any surface, hit slopes, hit ground and slopes, hit anything. And this code never changes. So what we've done is we've made this code safe for adding new features and being extensible without having to rewrite it or change it, which seems like a very small thing. But imagine how much easier your life is, where you don't have to hunt in that large line and then find the bit and add the right comma and put it in and figure out, where do I put the line of code which alters what ground it is? Instead, we can go to, in this case, this found thing, which is the dedicated portion of the surface. So now for the first time, let's have a look at this. This is a surface checker. What does it do? Well, it checks the surface. It's the same code we saw earlier, but it's just been given a job. We know this involves the mouse ray. We know this involves physics. We know this involves all of that. But what we really care about, is we need a thing which we can say, did you hit a surface? If you did, give me a thumbs up. If that worked, give me a position. So we can take that entire concept, all that functionality, and boil it down to a surface checker. And again, it's the exact same code. It's just no longer are we talking in terms of raycasts. We're talking in terms of surface checking. So when there's a dedicated behavior or a certain piece of functionality, if you encapsulate it or wrap it in a feature or a class, the rest of your code suddenly becomes self-describing because you're talking between systems that know about each other. If surface is there, spawn a thing from the spawner, versus if physics raycast something input mouse position, instantiate this game. All of that's nonsense. What you really care about is if surface, spawner, spawn. And once you can talk in those terms, your code's easier to read, easier to understand, easier to share, and easier to change, because we could have two surface checkers. We could have normal surface checker, slope surface checker. We could have normal spawner. We could have prefab spawner.
Random.
We could have resource spawner, random spawner, and the code doesn't change. It's still spawner.spawn, regardless of how that spawner spawns.
And also, just to make a plug for testability of your code, you could have a in-memory surface checker or a fake surface checker that literally, or mock, I guess would be the word, that literally just returns some random position, or the position that you specifically wanted to return for a test if you wanted to test, some other behavior that relies on the surface checker.
And I can give a very, very practical example of this. So, in my day job, yes, I have a day job, I do development and contract work. And one of them, at the moment, is I'm currently working on a VR project.
Ooh.
I won't talk too much about what the project is, but I will say I have this, which is a custom VR headset. It's the Pico, but it's been modded with all these cool dots and things. These are sensors. And so when you wear them, they can detect facial expressions, heart rate, all sorts of other fun toys.
Cool.
And so I'm writing code, which when this is being worn, it detects that, reads it, and does cool stuff based on heart rate. Now, here's the thing. This is running a service on the device, which I have to then subscribe to. I have to use an asynchronous thread and connect to it and get data from it and show it on the device. And that's all good and well, but that's a lot of mess and annoyance when I'm trying to just test something. And if I want to test something, I just need a number. This is heart rate. It goes up, it goes down, and I can test if it works. So I have written a heart rate system, heart rate service that uses this, and I've used a fake heart rate service. And then the rest of my code talks to the heart rate service. And so what I can do is I can say, when in editor or when testing, use the fake heart rate service, which I can then use up and down on the arrow keys to change it up and down to fake the heart rate. When it's worn, I can use the real one and get real data out of it. And that way, I don't have to slow down my entire development process to basically wait for the services to connect and all this other stuff to happen. And so that's, very good point, is that you can do a lot of, you can mock out portions. And this is where we get into the dependency injection stuff, which is out of scope. So we're going to pause there. But the point is there's this subtle change of like wrap it in a class or make methods out of it has a lot of hidden value that we're going to hopefully get to over time.
Yeah, that the indirection, just the surface that makes your code easier to follow and read. But yeah, I mean, I think that's a really great example of that headset. The example I always go with is the developers at SpaceX, they're not going to launch a rocket every time they need to test to make sure the temperature doesn't blow it up. So yeah, it's a good example.
Yeah. So I guess to cycle back to the whole, and this is just one thing I want to mention as well. So you'll see here I've got headers and various stuff. Just go back to the inspector version, the actual editor.
Let me pause. Let me stop this thing.
So subtle difference. Item painter 1, item painter 2.
Mm-hmm.
You'll notice they look different in the editor. One of them has two settings and one of them is just the item. So it's exactly the same code. It's just the difference here is I've put headers to label what the sections do. And this means that if I give this script to somebody, they know the dependencies are items that are required to make this script function, and the settings are things you can change to customize how it works. And this boils down to not quite self-documenting, but it boils down to making your code valuable and usable for other people. And I find these small little quality of life things are massively important. And we can go into a whole topic about adding the range properties and custom editors and stuff, but I don't think you need to go that far. All I'm saying is that I do these kinds of things with the implication that I know other people are going to use my code, and I want that experience to be as painless as possible. And the way you do that is you try to understand what a person's objective is. If you are using the item painter, you are probably trying to paint items. And so if you're trying to edit the item painter, you will probably try to do it in particular ways. You will try to change what item you are painting, or you're going to try to change what button or action causes the painting to happen. And so if you can anticipate the things that will change in your code, you can design to make it easier for other people. So I only mention that to say this, it's all part of the same ethos, whether it's talking about self-documented code or custom inspectors. if you can put yourself in the position of the person using the code, you can make your life easier by making it easier to read and easier to edit, which is the point.
Yeah, and now by encapsulating those, like the pressed and the paint field, now you're afforded the opportunity to actually expose more information about the class in the editor. And if you wanted to go to further lengths, you can create a custom editor, and you can get so much more out of this than you could have if you had just had this simple item painter. There's no way to really expose more to the editor.
And one thing I will say, this may seem like counterpoint to my previous one. If you go to item painter 2 again, you could do, and this is the same thing, you can put a tooltip header on some of these properties.
Oh, right.
So just right there on the space one, just underneath that one.
Which one?
Where the key is, the top.
Okay.
No, up higher.
Sorry.
Yeah, there.
Oh, I see what you're saying. Yeah, gotcha.
So you can put a tooltip.
Actually, I've never really used tooltips.
Well, it's pretty simple. You can just say, again, the key to press, whatever. This is an example of a redundant one that I would say you wouldn't need to do. But if you had properties that need to be passed in and there's certain conditions or logic. So this is subtly different from comments, because comments, again, are designed for the programmer. If someone is opening your code and reading comments, they're already a programmer. They shouldn't need comments to read your code. But if you're building a tool for people to use, there's a subtle difference between adding tooltips, because tooltips are telling you how you should use a system. And that can be very different. It might be hard to understand how the end result of the system works. If someone is opening the code to look at it, you should give them the benefit of the doubt they know how to read code. Or at least if you write the code well enough that it's readable, then they shouldn't need the comments. But that's very different. It's very hard to name a variable. This is the full exact definition of how you should use it under what context. So I will put a pass there and say I will frequently add tooltips when you may not necessarily need them, because it's a quality of life thing for the person using the end resulted tool that you come up with. But I think that's a very different argument than using comments in your code.
Yeah, Paul makes a really good point. Something that it's like a word that I've been using a lot at work with my associate developers is you really want to be explicit, I think, and in the way you write code and the way things are exposed. Like you're explicitly saying this paint key is the key that you're using to paint. It isn't the input key. It isn't the player's input. This is explicitly what I want to be used for the paint. And I think that's so valuable. It's something that if you're more purposeful about being explicit in your code, even when you look at this function again, like I'm saying on the surface, I want to check it. I'm explicitly saying I'm checking it. And there's no magic here. It's not like you're calling a function that both checks and then returns some value. You're explicitly saying I'm going to check first, then I'm going to explicitly check to see if it's found, and then I'm going to explicitly look to see if this paint button was pressed, and then I'm explicitly going to spawn at this position. So I think that's really valuable too, just being as explicit as possible.
Yeah. So the way I mentally process it is I say, if I read a line of code and I then have to reformat it in my head and say, oh, so what this says is, I could just name it the is I came up with and skip that entire first step. So it's not just about being explicit in my mind. It's about being explicit that I am writing down what the actual intent is in my head. If I have an intent, I have to use code to get there, but I don't have to expose the fact that I'm using code to get there.
Yeah.
If I want a character to move, I want to say character move forward. I know internally that's probably using transform.position plus equals blah, 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 but that's not my intent. My intent is move forward. And later on, if the reasoning changes, we've decided we're moving to a physics-based character controller. The fact that I have to change to rigid body.add force or rigid body.move position shouldn't change my intent, which was still the same thing, move forward. I just changed the implementation I chose to do the moving forward. And so they're very different things. The code should describe the intent of what I'm trying to do. This thing should do this action. And then there's implementation details that make that work. And those implementation details should be free to change. It just shouldn't matter how they're implemented. And I should be free to mix those around as long as the intent remains the same. And if the intent changes, then I rename the intent and I can then change the implementation details to match.
Yep. All right. So I think that about does it. Just to kind of go over an in summary, if you're starting to look at this code and your first thought is this is way too much code, this is going to slow down my game, you can rest assured it's not. Behind the scenes, again, we looked at this indirection when we looked at this not equals function, if you were to control click into that, you can see that Unity is already doing indirection all over the place. We're seeing it even in the most basic of functions. This isn't even a function call. I'm doing a not equal. You know what I mean? So that's
just symbol. It's a single symbol. Yeah.
Additionally, if you're talking about classes and your argument as well, it's better to have it all, in one class. Well, we can see that in the case of something like a coroutine. If we look at the decompiled code, well, Unity, or the compiler rather, is already creating a whole bunch of classes that you're not even aware of. And again, this isn't bad. It's fine. This particular piece of code added 3 classes. In Jason's example, I think he may have added 4. But it doesn't matter because we're talking about degrees of hundreds and thousands of classes where you're actually going to notice any sort of different, not 3 and 5 classes. So with that out of the way and dispelled, if we look at the actual now strategies we use, really it comes down to indirection and using, encapsulating concepts into properties, methods, and classes that have names that are easy to read and follow. Again, we're trying to bake the intent into the code. The intent is that we're checking the surface. We're checking to see if it's found. We're looking to see if the player pressed anything or the paint key more explicitly. We're not concerned about the implementation details. And that's just as important for readability as it is for maintainability and the ability to add more sophisticated behaviors in the future. Because like Jason said, if we go from the concept of, hey, we're going to do player movement using transform to, okay, now we want to actually support rigid body movement. Well, now I don't have to change any of the code up above. I just need to get down to the implementation details and perhaps implement another player movement class as an example. And on top
actually, I was going to say, I think there's a small example that comes to mind that we could do real quick to demonstrate exactly what you just said there. If you just make a class and call it mover, and it's a mono behavior. So this is something I see people do a lot, which is just do a public transform array.
What? Oh, transform array?
Yeah, just items or characters or movers, whatever, it doesn't matter. Yeah, and then just do an update loop where you iterate through those and add to the transform position. Yeah, so that transform that position, or yeah. Oh, yeah, it is transform, yeah. Plus equals
do forward or whatever. Oh no.
Yeah.
Whatever. Or I'm sorry. Yeah.
It'll be a vector by so transform, yeah, exactly, and then multiplied by time delta and speed. Just speed can just be 5, just hard coded or whatever. It doesn't matter.
Okay.
Yeah. So this is an example I see people do a lot, where they are kind of working in. Yeah, it's probably a good idea.
Oh.
So this is basically an example of people using transform as their base object. And this seems fine because you've got a thing, you want it to move, everything's good. But there will be a point where this code will scale and you're going to go, okay, now it's time to animate my characters. I have a character that's animating on screen. And what are you going to have to do? You're going to have an array of animations and go through the same thing. And for each one, do whatever. But here's the subtle difference. If you just make a class called character, and then have a function called move, and then paste that code in instead.
And I'll have a
character array, yeah.
Wait, let me just do this. Copy. I move this over here. I'm sure we're going to want to do that.
Mm-hmm. And then, that's just now going to be transform itself. Yeah. And it has to be mono behavior.
Ah, true.
Yeah.
All right.
Yeah, so now it's basically the same thing. So if you scroll up, now it may seem arbitrary. All we've done is taken transform and wrapped it in a character class. Why do we even need to do that? What's the real benefit that gives us? Well, here's the thing. Future decisions can now be made. So I could say, when we move, we're going to animate that. And the thing is, there is now a place where that happens. And the mover class and all subsequent classes which control movement don't have to change because we've decided to add animations. Or we've decided to add code which says you can't move because you're blocked, you're past the edge of the screen, or maybe you wrap when you get to the edge of the screen. All of this stuff is now additional behavior that can be added without impacting the code you're writing.
Yeah.
And again, the argument might be, but you still have to write it somewhere. True, but you don't have to write it here. And the more times you can keep deferring that decision, it means that you'll end up with that's only one or two places that really have to change. And this may seem really subtle, just to wrap it in a character class. But what you've actually done is you've given yourself a place where all of the behavior lives. And there's another benefit of this too, which is it comes back to that other thing we talked about. This is called the law of Demeter, which is we could have said character.transform.position, blah, blah, in the same way, because it still references a transform. But here's the thing. What if we change to a rigid body? Not only would we have to change it in one place, every single place that has ever referenced character, because we're not talking to character, we're talking to a character's children, that's exposing the internal workings of how character works. But if we instead put the behavior on character, he decides his own movement. So what we've done is we've encapsulated, again, the intent. The intent is a character should move. It is not a character should get his transform and tell his transform to move. And that subtle difference means that we can change inside of character what constitutes movement. It could be anything. It could be animations. It could be entirely transforms or rigid bodies or whatever. And this code doesn't change.
Right.
And that really small example is like, can be extrapolated for your whole thing. If you've got a UI, your UI should show and hide. It should turn on or off. It should give you input. It should animate maybe. But the thing is, how that happens is a separate conversation from what rules do you apply. When it shows, did you click this? Did you click that? And it's drawing those lines and describing it by intent.
Yeah. Yeah. And that's, again, it's like baking your intent into the code. You want this character to move. That's it. And then that way you could add so much more sophistication to both the mover and the character. You could have, if is blocked, and you pass in the character, and now you can say if not is blocked, now you can move. And then down here you can say, okay, well, now I want to animate after I move, or whatever the case may be. You can add so much more sophistication, and it can be, it belongs in its own place. The character is concerned about its own concerns and knows about what it's aware of, and then the mover is concerned with an entirely different subset of classes or objects.
And something I say a lot is, do you enjoy using your own code? And like when we talked about APIs, yes, you can document all of your APIs and go into heavy detail about what it does. But here's the thing. If you've never used an API before, and I basically said, oh yeah, here's what you do. You take the character, you reference its transform, you add the position of the transform, and you do it. Or I just say, character dot, what are the available options? Oh, move, character dot move. What does that do? Well, maybe if I pass in a number, oh, look, it moved. Like you can write, if your code is sufficiently well documented in terms of how it's written, it's kind of easy to explore it. So this is kind of another side effect that I quite like is, do you enjoy reading? Do you enjoy writing your own code? Like I like the fact that I can go back to that Painter 2 example, to scroll up a little bit. And yeah. And if I want to come back and go up to the top, if I decide to change this later, surface found and pressed, so down a little bit more to the update. Yeah, so I can come back to this in 3 weeks, and I can forget whatever, and then I can go, okay, I want to change this now. I was originally spawning whatever, these various cubes and things. I want to now, whenever I click on a surface, I want to start drawing a line, and I want to make a path that people can follow. I can look at this code, and I can say, oh, cool, I already have a thing which does surface checking. All I have to do is when a surface is found, not do the pressed paint line. I can say, start draw. I can create something called a line drawer, and I can say, start drawing line. When I release the mouse, stop drawing line. I can just reuse 3/4 of my code because I can read it. It makes sense and it's kind of clean. And there's something very satisfying about your code reading nicely and being easy to understand as you start to explore and change it, which is, again, really difficult if you have to talk in Unity terms. If you have to talk to people by saying, referencing rigid bodies and referencing line renderers and all this stuff, it's going to be so much harder than if you understand intuitively. To draw a line start to finish, what I'm really doing is saying, start drawing line, place point, end drawing line. It could be a line renderer. It could be Gizmo drawing. It could be Freya's new line rendering cool asset. It doesn't matter which line rendering tool you want to use. The fact is, your intent is start line, end line. And then the internal logic for how that works is kind of irrelevant, right? And that means that later on, if you want to do different kinds of line rendering, you know where that happens.
It's funny too, because some people were asking about the original item painter, like, oh, why did you put the check inside of the raycast? Well, there's an example. Like I might want to, if I find something, I want to draw a line, whether or not the player pressed anything. And so yeah, and it just makes it so much more flexible. You could put this above, you can put it below, you can it doesn't matter, so that's you really do get a lot. And it's so funny how we're just talking strictly like this whole stream is through the lens of making your code self-documenting and easy to read, but it's so funny how that leads to so much more. If you can grasp that one concept and approach it from that, because I think a lot of newer or younger developers approach it from the concept of like, oh my gosh, I need to make my code easier to maintain, flexible and testable. And that could be very scary for sure. And when I was younger, that was like, oh, I got to make this code better. But if you just start with the premise of like, I just need to make it read easier, that's it. That's all you have to do. And from there, if you can grasp that and use encapsulation and good naming conventions and indirection, it leads to this code that happens to be so much easier to work with too.
Because I keep going back to, like, do you enjoy using your own code? And if you find yourself copying and pasting a line that says transform dot position plus equals transform dot whatever plus transform dot whatever plus get component dot transform dot, I don't enjoy using that code. I mean, I don't know if you do, but I don't. And if you can take all of that code and turn it into a nice, friendly name, it's like I see this with character controllers all of the time. You see these giant code things where people are like, if velocity dot y is greater than thing and velocity max the abs value, mathf dot abs this and you're like, okay, but what is it actually saying? What it's actually saying is, if you're above the ground and the ground slope is greater than maximum standing angle or slippiness level, then do whatever. Like if that's what you're reasoning it out and trying to write. But what if you just use some indirection, took that entire if statement and changed it to, if ground is too sloped, then you could say, if ground is too sloped, do whatever. And there's no longer this sort of trying to decipher the code. That one little indirection is going to massively save you a headache when you come back to your own code later and go, wait, why exactly am I checking if this random value is greater than 0.37? What does that actually mean? Oh, it's actually, is the normal value greater slope than blah, blah, blah. What you're actually doing is this sloped? Yes or no? That is what I am checking with this line of code,
Yeah, and also I guess I should also say, because we're looking at two different examples, and this example is like, wow, there's so much here. It doesn't have to go from one to the next. You can do it iteratively, for instance, and you can do it all in the same class to start. Like this get key down, you could just say, you could add a method to this very class and say, is pressed key, whatever it is, key code. And now you can grab this, return this. I probably could have used some sort of fancy refactoring shortcut, but whatever. You get the idea. Now I can just say, hey, look, is pressed, and then I'll put keycode.space, key, and then, okay, look at that. Beautiful. But now I might say, well, shoot, I want to expose what the key is. Is that what you're going to say?
No, I was actually going to say, imagine now you've got this code. You want to have a completely different example of saying, you know what, I'm in a cutscene. I want to block all input. So you could now put one line above this and say, if input's blocked, exit or whatever. Yeah, and return false.
Yeah.
So as silly as that sounds, any place you've now used the is pressed sort of abstraction, you've now said all input has one place to be validated before it's ran. And you could decide later to add the functionality of adding a blocker. Imagine if you tried to do that when all of them were in lines input.get button. You would have to go in if input not blocked or you'd have to change the entire update loop. And we've all done this where you've had some scenario where you want to run part of the update, but not the other part. So you put a blocker and return, and then the whole thing breaks to then move the blocker and then move some code around the ordering just so you can get the block right.
Yeah. Or better yet, if you put this concept into a class or a mono behavior, you could just have something that disables that mono behavior when input is blocked or whatever you want to do. It doesn't matter.
And then you have an entire input object, and you could change it to be keyboard and mouse or different input systems. And
exactly.
All that kind of
the implementation does. The important thing is that the implementation doesn't matter at all, and that's like the key. It's this,
and you made a good point, is that we're not saying this one's wrong, this one's right.
Right.
We are saying this makes sense. You can write it this way, but as your code grows, don't fall into the trap of keep adding these extra things, adding the layer masks, adding the new conditions and values and whatever. Because all you're going to do is you're going to make the code base huge, and you're going to end up making these long convoluted sentences. Ask yourself if it's gotten to the point where that sentence can just be described as if does X, change it to a nice name. That's all we're saying.
And you can
that
keep
one
going.
thing, yeah, keep going. And so it's just, It's one of those things that like I get really frustrated when I see people say, but oh, I can't do that because it must slow things down. It's such a non-argument. It doesn't slow things down, but I will accept that it can be confusing and get overcomplicated if you do it wrong. And so it does take a bit of experience in kind of learning how to grow your software the right way. But it's certainly not an argument not to do it. It's an argument to learn how to do it correctly, I think is the big difference.
Absolutely. And just do it iteratively, do what makes sense, try to bake your intent. An example here is we were checking if a key was pressed, and then I was like, okay, it should be the paint key. And then it bubbled all the way up to, well, what is my intent? I just want to know if the player is painting. Maybe they don't even have to press a key. Maybe it's voice activated. Maybe they can say, I'm painting, and then there's I have some sort of API that or library that can key into the mic and use some voice recognition, and then that is the player's painting, So it's interesting how
and that's an example I've done with that whole idea of the voice thing. Is I have done examples before where I've been given a project, and the idea is you have to choose a word. So it's like pick your favorite color, red, blue, green, or whatever. And the original was the client was like, we're just going to test it. It's just red. We're going to test it with red. And so I built a UI that provided the word red to the system. And then later on, we wanted the ability to type it in. But then we're like, nah, people are going to type it in on their phone and they're going to get it wrong. And we're going to check casing and all this kind of stuff. I said, wouldn't it be nice if we had little icons for each color? So we did that. Then later on, they said, wouldn't it be great if you could just say it into the phone? And I could change all of these things. So we literally ended up having a voice command where you could use the Microsoft text-to-speech thing, and I'd convert it and then change it and cast it to a color. But all of this changed, and the entire rest of the code base didn't, because I put a barrier there that says, get chosen color. And how that happens is irrelevant. That's sort of the encapsulation gap. And so the intent was, get a color from the user. The implementation of how that happens is irrelevant to the actual logic I'm writing. That's one of those really big things. It's such a high-level concept to say, separate the code you write's intent from the implementation of how it works. And we're going to end up harping on that a lot in different ways, but I really want to stress, it's more than just put some names, classes, and functions. There's a philosophical reason for this that will make your code so much easier to work with, understand, and scale.
Yeah, I just started going ham on it.
No, go for it, man.
Yeah, just to show that now you can take, there's this concept called feature envy, where you start seeing that, all these, these methods or this group of code happens to be referring to a lot of variables that can move somewhere else. In this case, I was thinking, well, I keep saying is player, etc. I could just have a player and then use its context to say, okay, is he painting? Dot is painting. So something like that. But yeah, we could continue on this for a long time, I'm sure. But I think we covered the gist of it at a high level.
Just a couple of like short questions to answer, so we'll just sort of skip to the end. One of them is someone says, I don't know the name of this particular thing, and they're extending functions. That's called Fluent. So basically, people will make a Fluent API. That's the name for what that is. There's basically Link does that. It's Fluent accepts Fluent statements and stuff. That's whenever you have something that returns itself. Also, watch Charles' video on the builder pattern. It'll explain that concept in more detail. One thing I would make a note on is someone says, I despise one-liners if they don't contain some sort of null check. I actually really don't like null checks, and I hope the very first clip of this video demonstrates why. Is when you dive down into the not equals or the null check, you realize it's actually doing like 10 things. It is doing a lifetime check for the object. It is doing casting checks for the types. It is doing multiple different things. So it may seem really subtle to say, oh, I'm just checking if thing is null, but it's not. There's a lot of work that goes into a null check, especially in Unity, because it's got its own life cycle on top of the other stuff that it's doing. So I think it's a much better idea to practice defensive programming, which is that rather than along the line checking that everything is null, you write your code with the assumption that it works correctly, that everything is provided, and then you throw those null checks only on the providing of data. So if you've got a system that requires 3 objects and does loads of work, write the code assuming it's all there, and then do one check when the thing's supposed to run. If they're not there, throw an exception. And it's the job of whoever binds it above you to set those correctly. And if you're the one writing your own code, you can keep that going up the chain, writing it correctly all the time. So there's only 1 or 2 null checks that need to be done. And there's ways to even avoid those 1 or 2 null checks by using something called the null object pattern, even further up the chain. But the idea is, null check is kind of like exception checking or logging. These 3 things sound like they make sense in the middle of your code, but they're not part of your code. And in the same way that we're trying to avoid comments, because comments are not part of your code, your code shouldn't look like null checks. It shouldn't look like logs. It shouldn't look like these other things. It should be the code that describes your intent. And your intent is, I want code to do X, not I want code that does this, but checks that this is not there and also logs this message when this. That's not what you're writing. You're writing, I want to move the character forward.
Yeah.
And you should assume you have a character so you can move it forward. And you write your code with that understanding in mind. And if it doesn't get set correctly, that's not your fault. But if you're in charge of the next step up, which is the assignment of the character.
Oh, I think we lost him.
Oh my God.
No, you froze for a second. You're back now. Yeah, go ahead.
Well, either way, the idea is null checks are you pausing in the middle of what you're doing to make sure everything's there. There's very little things you do in life where you stop and say, so I'm making, I'm making toast. Oh, is the toaster still there? It's still there. Okay, good. Oh, good. Is the toast still there? Like, you don't do this. Yeah. That's not how. So instead, you check, do I have everything I need? And I start working. And if you don't have everything you need, you shouldn't start making toast until you have the bread and the toaster. So you go back one step. And so you keep pushing that out and until there's a setup scenario which sets things up correctly. Yeah. And if something gets set null, it has to be set null. And how do you avoid that? Well, there's an onValidate function and there's mutator functions where you can check when the value changes. And when it changes, throw your exception logic there. You shouldn't be checking an update if something is null, because you should never be in a state where a thing is allowed to be null in update, if that makes any sense.
Yeah, no, that's actually a really good point, and probably something that deserves its own stream and video of null checking.
Yeah.
And that pattern is something I've been using a lot.
Null handling and exception handling is definitely two things we could probably do a big talk about.
Yeah, because you're right. It's so funny. It's something that you're like, of course I'm going to check null. Like that's good practice, but it's like, no, you don't want to be checking all the time. You want to let that bubble up, assume that it's there, let down at the bottom, whoever's returning that value, that data, it can return either some null object, which is a great pattern, or yeah, just not null. Hey, Jason Wyman, thanks for the super chat. Appreciate it, man. Thanks for the stream, guys. Interesting discussion as always.
And while you're liking and subscribing to our stuff, make sure to also like and subscribe to Jason's stuff.
Yes, Jason's stuff is amazing. It's I envy you, Jason, because you have the ability to just sit in front of the camera and describe things where like I have to write scripts because I can't seem to get my mind together. So definitely love Jason's content. My stuff is more like skits, but if you would like more like, talking head, explaining things kind of like what we're doing right now, Jason's content is amazing. And he's got great
He's got a new course coming out too. Yeah.
Yeah. The courses by Jason are amazing. Definitely check those out too. And I think this is a great pace to stop.
As you can see, you could go on forever, so we should probably call it quits now. But
I'm going to make this easier on my clip editor. He's like, wait, do I put a clip here? Do you want me to talk about the thing with the... No. Well, thank you all for being here. Jason, thank you as well for being here. And Jason I want to say that Jason came up with all of the examples ahead of time. I was just going to spitball it, but he was like, we should probably have some code examples. So thank you to him for doing that. And here's the question that comes up every stream. Does Jason have a channel? Yes, he has a channel.
Yes, I do technically.
There's no code. There's no videos on it, but there are great playlists of all the videos that Jason finds valuable. So if you go to my channel homepage and scroll down to the bottom, I have like a list of my featured channels. Jason Wyman's in there as well, and also Jason, his channel's there. He's got a red avatar. So yeah, just again, if you guys like this, please hit that like button. Please subscribe to my channel, and if you'd like to support the channel, there's various ways to do that. You can go on to Patreon, and you can become a patron there. They have 3 tiers. And then we also have a merch store. So if you want to check that out, we have a pretty cool like zombie code sticker that I came out with. That's also in t-shirt form. You can check that out too. So.
And if there's anything we didn't cover or anything that we I know we glossed over a lot of things. If there's a particular thing that's like, wait a minute, you kind of vaguely touched on null checking, but you didn't go into it, or you said logging once. How do you do logging? If there's something like that, write it in the comments of the video, and we'll look into making a video on those things.
Definitely.
Or join the Discord. We're on the Discord too. You can contact us there.
Definitely. All right, guys. Well, thanks again. Have a great Sunday, and until next time. See you later.
Good luck.